Hi everybody. In this video we're going to talk about using this expression here. So use the expression the square root of x sub 2, which I'm just going to call x2 minus x1 squared plus y2 minus y1 squared to find the distance between 2 points in 2D. 2D stands for 2 dimensions. Okay, so here we have a two-dimensional plane. So we have an x-axis, that's one of the dimensions, and we have a y-axis, that's the other dimension, so 2 dimensions. All right, and we want to find the distance between these 2 points that I've drawn here. So we want to find the distance from here to here. Okay, and let's just go ahead and label this point over here. What point is that? That's the point 1, -4. And if we call this point 1, then this is x1 over here, and this over here is y1, okay, which just means the x value of our first point and the y value of our first point. And this point over here, which is 4, -6, that's the point 4, -6, and we can label this x2, which just means the x value of our second point, we'll call that our second point, and y2, the y value of our second point. So before I actually go ahead and use this expression, let's talk about where this expression comes from, because you might be thinking to yourself, I thought we were doing the Pythagorean theorem. Where is this messy thing coming from all of a sudden? Well, this actually comes from the Pythagorean theorem, because what we're trying to do is we're trying to find the length or the distance from here to here. But with these 2 points, if I were to draw a line from here to here and then another line from here to here, what do I have all of a sudden? I have a right triangle. Okay, and this side of my right triangle, which I just drew, is the horizontal distance between the 2 points, and this side of the right triangle is the vertical distance between the 2 points, and the hypotenuse of the right triangle is the actual, what I'll call the straight line distance between the 2 points. Okay, sort of as the bird flies from here, or as the crow flies, or whatever it is, from here to here. And this is what we're actually looking for. So what I'm going to do now is I'm going to call this A, I'll call this B, and I'll call this C. So really what we're trying to find is the distance from here to here, which is the hypotenuse of our right triangle, because it is opposite the right angle there. So let me just write out the Pythagorean theorem again. It is a squared plus b squared equals c squared. I'm just going to put the c squared over here this time. Okay, so really I'm looking for the value of c. That's going to tell me the distance between the 2 points here, the 2 dots that I've put on this coordinate plane. Now, what I can do with this equation is I can get the c all by itself by taking the square root of both sides. So if I take the square root of this side and this side, then that cancels out over here, so I just have c, which is what I wanted, and then I'll just copy this again. So c is equal to the square root of a squared plus b squared. You can see how this is starting to already look like this expression that we have over here. Now, you know what, let me just so I can, so it ends up looking exactly the same, let me call this one, actually, I'll call that B and I'll call that one A. It really doesn't, with the legs, it doesn't matter what you call what. I just want to make it so that it ends up looking exactly like this over here. So if I call this A, so this is the horizontal distance between the 2 points. Well, how would I find A? How would I actually find the horizontal distance between these 2 points? What I can do to find the distance between 2 points is I can subtract the x values. Okay, so in other words, I can see pretty clearly here that the distance between these 2 points, let me just make this thicker. I can see that the distance between this point and this point horizontally is 3, right? So from here, I count 1, 2, 3. So I know that A is 3, but I could have also figured that out by subtracting the x values. So 4, because remember, this point over here was at the x coordinate of 4, and this point over here, well, this dot over here was at the x coordinate of 1. So I could have also figured out that it's a horizontal distance of 3 spaces between them by doing 4 minus 1, which is x2 minus x1, right? So I'm not actually going to write 4 minus 1. I'm going to just write this whole thing out again. And instead of writing A over here, I'm going to write x2 minus x1. Okay, in this case, x2 minus x1 is equal to 3, but I'm writing it out in general now. Okay, plus b squared. Well, how would I figure out b? Remember, b is the vertical distance between these 2 points. How would we figure out what the vertical distance is? Well, this point was at a y value of -4, and this dot over here was at a y value of -6. Okay, so there's a vertical distance between these 2 points of 2 spaces, 1, 2. And another way that we could have figured that out is by subtracting the y values. Okay, y2 minus y1 would actually tell us exactly what b is. It'll give us this side length over here, this vertical distance. Okay, and then let me just copy the exponent over here. All right, so now we have exactly this expression over here, okay, which tells us the distance between these 2 points. All right, so if I just plug, hopefully you understand a little bit where this expression comes from now. And if it's still not a little clear, then we'll actually use it now, and hopefully it'll become even more clear as we go through it. So x2 minus x1 is 4 minus 1, which is 3. Okay, so I have c equals, I'll write it all out, 4 minus 1 squared plus, and then y2 minus y1. So that is -6 minus -4. And then let's not forget the exponent. Okay, so if I continue now I'm going to simplify this. I have 4 minus 1 is 3. And 3, again, is just the horizontal distance between the 2 points. Okay, and then let's put the exponent on that. Plus, now let's figure out -6 minus -4. Let's work that out on the side. -6 minus -4. Minus negative becomes plus. So we have -6 plus 4, which is -2. All right, so let me write over here plus -2 squared. Okay, now, again, this, well, forget about the negative for a second. 2 is the vertical distance between the 2 dots. Okay, so it's it's this leg of the right triangle. All right, and if you're worried about the negative, don't worry about it, because when we take this number and then square it, we'll get a positive result. So don't worry too much about that negative. So the absolute value of this number, 2, represents the vertical distance between these 2 points. And so we're almost done here. We're just going to evaluate this now. So c is equal to the square root of 3 to the second power, means 3 times 3, which is 9, plus -2 to the second power means -2 times -2, which, as I promised, is a positive number. It's positive 4, right? A negative times a negative is positive. So we have over here c is equal to the square root. Now I'm going to start writing my equal signs this way. So c is equal to the square root of 9 plus 4. So 9 plus 4 is 13. So c is equal to the square root of 13. And let's just go ahead and we'll round that to the nearest tenth. So what I'm going to do is I'm going to get my calculator over here and just type in 13, and then hit the square root button. And then if I want to round to the nearest 10th, here, this digit over here, right after the decimal point, that's the 10th digit. And then I would look at the next digit over to figure out what I should do with this digit. So remember, if this digit is a 0, 1, 2, 3, or 4, then this digit stays the same when we're rounding to the nearest 10th. If this digit is a 5, 6, 7, 8, or 9, then this digit gets bumped up one. But this was a 0, so this is going to stay the same. So I will say that so this is approximate, I forgot what it was. What was it? 9? Oh my gosh. It was, well, it's got a, oh my gosh, that's embarrassing. I forgot, it was right there. It's got to be between 3 and 4, right? Okay, so it must have been 3.6. Okay. All right, so this is approximately equal to 3.6, which means that from here to here is approximately 3.6 units long. Okay? All right, so that's how we can use this expression to find the distance between any 2 points. And don't worry if x2 or x1 or y2 or y1 are negative, like over here you saw y2 and y1 were both negative. Don't worry about that. Just remember that when you're doing it, this minus symbol over here is separate from this negative, so you have to write them both. You have minus -4 in this case over here. All right, so that's how we use this expression to find the distance between 2 points, and it comes from the Pythagorean theorem. All right, so that's it, and have a great day.